Hello and welcome to JavaScript Evangelist. Today's video is going to be really amazing and different, and we are going to do GoLang in this video, and Albert is going to help us with that. So Albert is a really awesome GoLang developer. He's going to teach us become a master at GoLang, and you can check out his channel, and the link is in the description below. On to you, Albert.
Hello, everybody. Welcome back to Albert's Code Lab. So today we are going to have something fun here. So we're going to start a pair programming session. And here I have Ajinkya join me as a guest. He also has a YouTube channel. Ajinkya, maybe you can explain, introduce yourself to the audience and maybe promote your YouTube channel as well.
Okay. So it's a great pleasure having me on Albert's channel. And I run a channel called JavaScript Evangelist where I teach everything or maybe the recent trends about JavaScript. And I love Go. And as you can see, my channel's icon is a gopher, not a JavaScript icon. So yet, that's why I'm on Albert. Like we are doing this stream for GoLang. Yeah, let's go.
Yeah. So for today's content, because like I mentioned on my previous videos that I teach Go, so Ajinkya emailed me and said he wants to learn some Go, and I said, well, since we are both YouTubers, instead of me teaching you, we can just collaborate on this teaching material together. So in this video or in this series, I'm going to write a calculator in Go. So I just call it calculator. So this will introduce you the basics of Go programming language, and you do not need to have too much prior programming experience in other language. So I will start from the basics, but in the course you will learn more than the basics. For example, first you will learn some fundamentals of programming and the basic math operations like addition, divisions, multiplications, subtractions. You will learn control flow and the data structures. Like in Go, you will learn what is an array, what is a slice. We will learn some more generic and abstract data structures like stack and a queue. You will learn control flow like if, else, switch, and for loop. You will learn basic I/O. I/O stands for input and output. So you will know how to read information from the terminal or a file and how to output information back. And then we'll get into some more kind of computer science stuff. Like since we are writing a calculator, and you can see this picture, maybe I can make it bigger. So this is like for example, I can open a terminal here, right? So for example, if I have Python, I don't have Python 3 because
maybe Python just Python. Oh yeah, you have Python.
Yeah, so it's just not, the name is not Python 3. So for example, on the left-hand side, this is a screenshot of this calculator written in Go. And on the right side, it's just Python, right? So it's like a small interpreter, right? So I can do 10 minus 2, it is 8. And I can do like, for example, I can do variables. I can do variables and calculation together. And let's see what is BB. So you see, so actually in this calculator, we're not just going to write arithmetic operations. We're also going to write a little parser that can take our input in the terminal as a string and then parse it into like a computation tree or a graph. And then we will compute that into a final answer. So that's why probably in the fourth section, we'll get into like lexing or tokenization and finite state machine, regular expression, and the kind of recursive data structures. And if we have more time, we'll get more like object-oriented design and concurrent programming Go. But that's probably not in this small project. Okay, so how does that sound, Ajinkya?
Yeah. So far, it's kind of exciting Because what I seen is I had an expectation that when you had mentioned before that we are going to do a calculator, so normally people would just type one, and they would type another number and it would get printed out. But over here the interesting part is you are even able to assign the values to a variable into the terminal. So that is something interesting to me, and yeah, I'm excited to see how it is going to happen.
Yeah. So this video will probably just be like 30 to 40 minutes. We will not be able to get over everything, but that we will definitely get into variables in probably the second or maybe the third video. But okay, now I'm just open a online IDE here because this is kind of interesting. The GitPath is like a Chrome extension, and if you have this extension, you can just open your Git repository in a remote Docker, and then that Docker will open a cloud-based like a. It's almost the same as virtual VS Code, right? And then you can just edit in your browser. Sorry? Yes, yes. So I don't have to install any environment locally. Also, I have local installation. But the reason I'm introducing this is like if you are watching the video, I mean like the audience, and you do not have Go installed and it's your first time installing programming languages, is kind of challenging. So to save your time, you can just have this extension, and then you can fork my fork this project on my GitHub, and then you can just start to use Go, because here like you say Go is installed, and then I can actually look at the version of Go, and it's 1.12, so it's pretty recent. It's not the newest one, but it's the second newest one. Okay, actually it even have other language like Rust. It has Python 3. Oh, of course, it has Node.js, right? Yeah, and their Node.js is actually quite recent. It's 10.15. The reason I'm mentioning this is like, first, I like this, and also GitHub is sponsoring me, so sort of just have to deliver the advertisement. This is with their website. You can check it out, and it's free. Yeah. Okay, so let's go to projects calculator. Project calculator. Okay, as you can see, I already have this program written down, and let's just compile it. Or actually, if this is your first time using Go, Go is a compiled language. That means every time we need to do Go build, and then we need to build this main. But of course, in this case, I am already in this folder. I am already in this calculator folder, so I can just say Go build, and that will find all the dependency. And if the dependency is not there, it will download it from internet, and then we will get a binary out. Yes. Yeah. Yeah. So I will explain this later. But now you say we get a file at in this calculator folder. It's just called calculator, because if you do not supply a file name, it will just use the directory name. But since this is a binary, this is basically a program you can run. So now I'm just running the calculator. Actually, let me make my font bigger. So because some people will watch on their phone. Now I have 1, I have 2. I can do a plus, of course. I can do a minus, but I do not support floating point yet, so that will be a lexing error. But the interesting thing is, actually, I have very good error reporting. So it's a lexing error character period is not expected after a number. So with this, actually, I'm trying to say, like, instead of just write a program that barely works, we will write a program that is very kind of correct in a computer science sense, right? We don't have put floating point, but we can try to make it better in this video session. Let's say division. We support division, but of course, if you say 13 divided by 4, I just get 7 because I don't support floating point, so I just get the round. But of course, as I introduced before, we support variables. That is kind of interesting. We support variables with like negative number, and we can do that. And we can do that with another variable, and that is C. We can even do many layers of, for example, we can do layers of parentheses, sorry, like that, right? Because okay, sorry, yeah, that's a terminal issue, right? So we can do parentheses. So that's really like a basic version of calculator. Of course, we do not do like percentage. We do not do scientific notation, because for that part, it's mostly just a parsing problem. Okay, so that's enough about. We don't do Excel. You just basically need to Control C. Okay, so that is a basic introduction for the program we are going to write. And just now I mentioned Go is a compiled language, so you need to do Go build. But you can also just do Go run, and you can run the program you here. So this is like JavaScript or Python that you can basically treat Go as an interpreted language. You can just run a file. What Go compiler is doing is Go compiler will compile this program and put it in a temporary directory, and we're just going to run that temporary binary. You say like that's again. So basically, during development, people usually just do Go run, and you do whatever you are going to run. And when you are done with it, and finally you are going to release your program, people will do Go build. Okay, now let's get back into this module file, Go mod. So here we know our Go version is 1.12. So I think before 1.12, Go does not have a module support. Go has packages, but it does not have modules. What it means is before 1.12, let's say, let's look at a let's look at some packages here. For example, I have a package called github.com/ this repository. So before Go introduce the concept of a module, those packages have to install globally in your system. So it's like if you have two projects that is both using Cobra package, but maybe project A is using a different version from project B, then there will be a problem because you can only install one version of the library globally in your system, right? Then maybe you can just develop different project in different virtual machine. So actually, that's what even I did. I have like I have like virtual box here, and in that I have like one or two Ubuntu. Okay, in this case, I have one Ubuntu. So that's like literally there in this Ubuntu, there is just another Go project. That's not very convenient. So the community had some kind of experiment with other like version control system, but then they finally decided to use this version control mechanism. So it's just Go module. So in the Go module, you will specify the library you want to use and the version of it. And once that is done, Once that is done, the Go module is still going to install those globally, but it enables you to install different version in different projects. For example, in this project, I'm using 1.7.1, but maybe I can have another version that is using a totally different version. It does not matter. So that's like a short introduction to Go module. But of course, maybe we can have a dedicated video section to just go over everything of it. Yep. Yep. Yes, when you are doing import, you don't have to care about the version. You just import the name or the like the directory. And another thing about Go, and that's kind of interesting, is like Go's style of importing is like kind of is just like importing a directory, right? Because in other language, usually you just import a namespace like that. And maybe in Node.js, it's like import something from a directory, and that directory is like a file, right? So, but in Go, you just import like that. So basically, in Go, you can only import the whole module. You do not import like a function within that module. Once you import this, sorry, we are doing import. This is called package. A module is the actual distribution of that package, right? So you can think of if it's like in Java, it's like object-oriented language. When you are importing a class. A module is like an instance of that class. Anyway, so where is this code, right? We can actually look at the system variable. There's a GoPath. So this is actually let's list GoPath, and in GoPath there is a directory called package. So that's where, and in package there will be mod, right? So that's module. That's where all the module is put, and so right. Like this is just fold directory by directory, so it's like it has the same layout as like a GitHub directory. Yes, so basically you can change GoPath. You can change GoPath to a different path. Yeah, so actually before Go module, that's what people do as well. So for each project, they have a different Go path. But now we don't have to do that because Go module is intelligent enough to figure out, like we can just have one Go path, but everything will be taken care. There is also another environment called Go bin, I believe. Oh, there's no Go bin, sorry. But some people will have a Go bin. That's just where the Go compiler is. Oh, Go root, sorry. Yes, Go root. This is where the Go compiler is. Yeah.
Okay, I
So that's
think
basically,
since you mentioned GoPath, and since you mentioned Go mod, normally on my machine, I have a GoPath set up to a particular folder, and whenever I'm going to create a new project, I have to create it inside the src folder of that particular thing. But in your
yeah,
case, you're not doing that. Like, how did
I'm
you
not
do
doing
that?
that.
Yeah.
Yeah, because with 1.12, you don't have to do that anymore. Yeah. Okay, now that's some basic introduction of how Go build pipeline works. But we don't have to worry about that too much because I think most of our audience are not experienced programmer like you. So uh, let's start with basics. So of course, I will open a new project here, right? Oh, this calculator, and let me go out and let me just open a make dear calculator string or calculator live. Okay, Okay, now I'm in this. So in this, there's nothing. Let's just create a new file. Let's just call it main.go. So of course, this program consists of many parts, right? First, we have input. The input is just something user type on the terminal, and that's a string. We need to take that string and parse it to like a computation structure, and then we will compute that structure to get a number out, and then we put that number back to this loop again. However, we're not going to do that in this video. In this video, we're just going to write some basic, introduce some basic Go functionalities. But of course, I believe, Jinkia, you already know most of what I'm going to do here, right? So let's say in Go, this is how you do, like this is a variable and this like 1 plus 1, and then you assign 3 to this a variable, and this column just means this is a new variable. So if I do that, that will not compile because you have already declared a, so you have to do, you just do a equal sign. That means, yeah, that means assignment. This is a declaration. Okay, so let me import some modules. First, in the standard library, there is one called format. You can use format to print. This just means print line. Let's just make sure this actually wrong. Okay. Oh yes, sorry. Thanks for that. So in each package, you have at the first line, you have to declare which package this is, because in Go, one package can split into multiple files. So the Go compiler need to know which file belong together. Okay, and also in Go, you don't have to have this semicolon. Like you can have it so you can write everything in a single line, like that, if you want to, right? But if you just write it in multiple lines, you don't have to use semicolon. I think that's great. Yeah. Okay, now let's write something more like a calculator. Let's just say we have a thing called compute. And what compute will do, well, actually, let's first write a function called add, and it just add x and y. It returns x plus y. So this is a basic addition, because the Go is statically and strongly typed. Like this xy is the type for the argument. This is an integer, and the return type of this function is an integer. So you just write it here. If you come in from some other languages, maybe they declare the type at the beginning of the function. So this is just a syntax design. So it's not that special.
And I think as well you have smartly omitted the type initialization for x, because I think it is considering x and y as int in the arguments.
Right. So if x and y have different have different types, for example, like that. Actually, in Go, it's not called double. It's just called float 46, right? So then you have to write the type for each variable. But if they have the same type, you don't have to do that, right? So, thanks for mentioning that. Okay. This is addition, and the answer is pretty obvious. So in a kind of in our program, we're just going to kind of implement 4 operations: addition, subtraction, multiplication, and division. Yeah. So of course you will think, okay, so it's just like that, right? That's quite simple. So for division, we have some problem. If this is 0, then this will break. But let's worry about that later. So now we have those 4 functions. However, what we are going to simulate is, let's have a user input like that. Okay, maybe we have a user input like that. Oh, actually, I think this will get you 0, so maybe that's good. Yeah. This is our user input. How do we get the input from the terminal? That's a different thing we need to worry about. But let's assume we already have this input. How can we just go through this input and get the result, right? So maybe we have some general function like, let's just call it compute. And the compute will compute a string and give me back an answer. So here I'm just going to compute this input. So that's what we're going to do. So then we're going to, well, we will get into a little bit of algorithm and data structures. So let's divide this problem even further into one more step. So instead of compute a, how do you say that? Instead of computing, instead of parsing the string and compute, let's just assume we have a parsed version of this. So basically, we need a data structure that we can directly compute on. Maybe that's like a list of number. If it's a slice of number, we can just do a for loop and do addition, right? So let's assume we are just adding all the number. Then in this for loop, we can do for number in range. So this is just looping through all the elements of input. And here we can have a sum. And we just add this number to the sum. And we can return this sum. So that is a possible way of doing this, right? We have 1, 3, -8, 10, and 2. But of course, if we do that, unexpected sum at the end. Oh, there's no let. Like, sorry, I'm writing other languages. Yeah, undefined parsed, a column. So that will compile, but of course that's incorrect, right? Because we're just doing addition here. We're not using other operation. So basically, when we parse this input, we want two target. We want two results. First is we want to parse out those individual numbers. We need to have a second operation or operators. This is, well, I will just call it operands. So this is a list of operands, and I will remove this this minus sign because this is basically a subtraction. So
We are also going to have a separate array of the operations that we are going to do.
yes. So basically, what we are going to do right eventually is we want to have a parse function, and it takes an input as a string, and it will return two things. First, it will return operands, and then it will return operators as two different lists. So that will be our goal. But let me comment this out. But now what we are doing is, instead of writing this function, let's just assume we already have the result of this function, and let's try to implement the compute first. So now, of course, we need a way to simulate. We add. So the first one is add. The second one is sub. The third one is multiplication and then division. We need a way to put them in the same list. But the problem is they are different functions, right? So how can we put them in the same list? So in Go, actually, you can define a type, right? For example, you can define a function signature as a type. So I will just define a type as operator. And the operator is a function that takes two arguments, x and y, and return an integer. So that is the type. Now, once we have this type defined, you can sort of think of different function implementation as an instance of this type. So it's like this is a class, this is an instance.
So since I'm from a JavaScript background, so this
Yeah.
looks like an interface to me.
Yes, this is like interface in TypeScript. Yes. So if we have this, now we can have a slice of this operator. Now you see the arrow is gone. So of course, in this compute, we need to change our signature. First, we need operands. That's just integers. And then we need operators. A slice of operator. Okay. Operands and operator. Okay. Now we have that. So here, notice that the operand is always one more than operators, right? There are 5 and there are only 4. So what we can do is instead of do a for loop like that, we still need the sum. Well, actually, this is not sum anymore. This is more like a result. But now we need an index to track where we are. So let's just call it I. And then I will write the index in the old-fashioned way. So it's for I, or actually, since I'm going to write a for loop, I don't need I outside. For I equals 0, I smaller than the length of operator. So that's from 0 to 3, I plus plus. And then what I'm going to do is the result. So here, let's think of this. What would be the result here? So it's like we will compute this. So okay, the first one is 1, 3, and it's addition. So then this will become 4, and this is gone, right? And then it is 4 and 8. This is sub. So that's minus 4, and this is gone. So we're just kind of popping out information from those two lists. But we don't need to modify the list itself. I'm just doing that for demonstration. We can just kind of loop through it. So then the result does not start with 0. The first default result will just be the first element of this operand. So then what we can do is result equals operators I. So that's a function. Remember, that's a function. And what we can do is result and operands I plus 1. Typo, sorry. Okay, let's try it. Yeah, that works. Is that true? Minus 4, 4 and minus 8 minus 4 times 10 minus 40 divided by 2. Yes, minus 20. Yeah, that works. So another good thing about this approach is that we're not hard coding. We're not hard coding like those symbols into this, right? Another way might be we'll just make this as a string, right? This is just a string, and then we have those actual symbol in it. But if we do that, we have to do a switch statement inside. then we cannot extend this program. What I mean by extension is now another person can write another operation. This operation may be kind of exponential, right? They can just write exponential, and maybe exponential is like that, and then they can just do exponential here, right? They don't have to change compute at all because of the compute text interface. Yeah, so that's kind of like a little bit object-oriented design here. Yeah. Okay. Wait, what's wrong with it? Oh, I plus 1. Yeah. So that we have our compute, and that's pretty. Wait. Okay. I did too much redo. Yeah. So here you have like a warning, because in Go, anything that starts with a calculator is a public method or public type. So that's or in Go it's called exported, which means now we're just in main. But let's open a new folder. Let's just call it compute. So in JavaScript, each directory will be a package, and in the same package, every file belongs to that package. Okay, so now let's move those stuff. But since right now we do not have much code, we'll just use the same name as a package name, just one file. And of course, here we just have to declare the package name, because by default, by convention, the package name is the same thing as the directory name, but it does not have to be. So you can actually have a different name than the directory name. But that will be kind of confusing, right? So our convention just having the same name here. Yeah. So if we do that, now we can do an import. So now this is where Go module come from. So if we do relative import like that, let's see what will happen.
Okay, I think you're mixing JavaScript again.
Yeah, actually that's what I want to talk about.
Okay.
So it's just a typo.
Okay.
Yeah,
Oh, you
but
can do that.
yes, you can actually do relative import in Go. It's just it's not a best practice. Because actually in Go we want to mirror like the actual kind of the distribution directory, right? Like you, for example, when you import something from GitHub, you literally write down the kind of URL. You can do relative, but the thing is, if you are going to do relative import, it basically means this package is not going to be shared outside your program.
Okay.
So, but that's kind of encourage you to encourage coupling, right? Because if you know this package is never going to be shared outside your program, maybe you will just write it kind of in a messy way, right? But in Go, like the kind of philosophy is, no matter what you write, no matter it's internal or external, you just write it as a package, assuming other people outside your program will use it one day.
Yeah.
But anyway, that's another topic. Here, I just want to say, we can use this operator because it's start with a calculator, so it's public or it's exported, but we cannot use those functions anymore.
Yeah.
Right? Because they are a lowercase, it's not exported.
Yep.
So what we need to do is just that. Yeah.
So normally I see this when I'm using Visual Studio Code, and normally after every save, my Go doc runs, and it suggests me that if I'm exporting a function.
Go doc.
Yes. So here, now it's not complaining, but usually it will complain that since this is exported, they want you to write. I mean, when I say they, I mean the Go doc tool we want you to write a document for all the public names. And that's a good practice, right? Because if something is public, you expect something other than you to use it, then you need to have documentation. But in this case, okay, yes, once I save, you see it's complaining. Yeah. So you can say operator is any func that computes two integers, something like that. Now this is gone, but of course they are still there. So they are not errors, because they are just this is from GoLang. This is not from Go compiler, so they are not errors. It's just kind of like a hint. Okay, so let's run this again, right? So another powerful thing about this design is those 4 functions are kind of built in, right? This compute package already gives the user those 4 functions. But if the user want to have their own functionality, they do not even need to change this module, right? I can just write my own exponential here in a totally different package. Oh, by the way, so in Go, the name of the argument does not matter, right? So here I can use A and B. That's fine, because the position is what compiler checks. So here I'm using A and B. Yeah, and then I can just do an exponential. But to do exponential, I need to import the math library. So I'm not going to do that, but I'm just going to demonstrate the capability here. So now we have this. So the next step will be kind of actually parse this string and get this 2 slice out. So for this part, it's still 2 jobs, right? The first one is like from terminal to a string. And the second part is from a string to actually operands and operators.
Maybe we can just read the basic terminal input and maybe do the parsing in the next video for the operators.
Okay, yeah. So nice. So let's first write a function called user IO, maybe. And so that will just give us a string. Actually, it's not. Oh, there's no output, so this is just user input. And let's just call this. Here, I'm going to directly do that. Okay. Okay, now every time when I'm doing IO, I have to check the documentation, or I have to look at my old code and see which to import. Yeah, internal repo. Okay, yeah. So I'm looking at my old code here, and so in Go, doing IO is actually quite easy because it has very nice kind of mirror to the Unix operating system API. For example, here, this is buffered IO. So buffered IO. We need buffered IO to kind of have a new reader. And new reader, you can just call read bytes. Then it just reads what you are inputting from the terminal. But of course, when you are doing initialization, you need to tell where to read from. And so we need to import the operating system library to say, okay, we are going to read from standard input. The standard input will be your keyboard or like your terminal. So yeah, let's is it here? Yes. And since we're importing a lot of libraries, a lot of packages, we don't have to type import multiple times. We can group them together.
So Buffio
Okay,
is an internal
yeah.
package, right?
Sorry? Yeah, they are standard libraries. So actually, let me put them. They are STD and they are mine. Okay, so they're not used, but that's fine. And now let's first create a reader. So this is a reader. And so basically, it's just like that. Yeah, right down. And this is bytes, but we are returning string. But so what we can do is just kind of converting bytes into string. That is fine. This is line. So what I'm saying here is like, I want to read all the bytes until I met a new line. So if I do X, it's like I want to read everything until I met an X. Okay. It also returns an error because any time you are going to do an IO operation, it might fail because it's actually going into the hardware and going to my physical keyboard. So that might fail, right? So we need to check the error here. But in our case, let's just get rid of it.
So Buffio new reader sets up your reader, and OS std in is going to read the single lines from your terminal.
Yes. Yeah. So now let's return. Okay, and this is called line. So now we can compile this, and you see nothing happened because actually that's true, right? Because I'm just reading it. It's right, and after I read it, I just kind of type it. So, but that will be kind of weird user interaction, right? This looks like something is broken or anything.
So I think I would, when you press enter, that then it should show something. That would be good interaction.
We can say please type your input. Oh, sorry, in Go, you need to use double quote for a string. A single quote is a character because, and this is new line. So although it's two character, but it represents the new line special character.
So for /n, single quotes are fine whenever you're trying to escape
So you
something.
have /n and you have /t. So this is like the tab on your keyboard, right? But let's try X here. So if I do X, you see, they'll keep doing it until I do X. Yeah, so this is like rate until you meet this and stop. Yeah.
What would happen if you use double quotes over there? Like, would it interpret something differently?
No, it will not compile because it's a different type. Can I use X type string as type byte? Because we look at the signature, it just reads a delimiter, right? It's just 1 byte.
Because I had always thought in GoLang you could only use double quotes, not single quotes.
Yeah, because there are different types. So this is a single character or a byte. So what I mean by that is, if we have kind of Unicode, it does not work because the Unicode is more than a byte. So you say constant, this is the actual value, 26,000 or something, overflow a byte, because a byte is only 8-bit. Which means you can actually, this is just from 0 to 215, to 255. So you can actually use integers as byte literal. That's also fine, but I don't know which one is this, so it will probably not work. Yeah, I don't know. But I think 64 is capital A or something, or lowercase a. I don't know.
So I think for each character we have a different set of codes.
Yeah, you probably know this, but I'm just kind of showing this to other audience. Yeah, so you can know the decimal or like the integer value and the actual character, right? 0 is none, and 64 is this ampersand, right? No, not ampersand. This the at, yeah. And so for ASCII code, it's just half of a byte. It's from 0 to 127. Um, but a byte has this much, right? But ASCII code only have this much. So it's like half of a byte. Yeah, I think that's probably just it for this video. Yeah. Do you have any other thing you want to discuss?
No, I think it was a good video, and I think we tried to cover a lot and not much as well. So it's a kind of a good balance, and that's great video, I think. So this is a good start for our journey on GoLang, like becoming a good GoLang developer. So it's a good video. Yeah.
Yeah. So trust me. So although this might be very basic, and if you are watching the video right now, you might be an experienced developer from other languages, but it's like the difficulty of this video series will kind of explode later. Trust me. Yeah. Okay. So thank you very much for watching this pair programming session. And my name is Albert. Make sure you check out Ajinkia's channel, JavaScript Evangelist. If you want to learn like a front-end development, that's a great channel to watch.
And I would definitely say, rather than subscribing me, keep subscribing to Albert channel, because I really feel it's going to be a great journey of GoLang, and I have a really good positive vibes on this video series that we are doing. And I would really appreciate that if we keep getting more subscribers to Albert Code Labs channel. Thank you.